Hello, I'm Dr. Harper. This video is an Operations Management BANA 3000 Section E02, Spring 2021, and this is going over homework number 4, which is inventory. So let's bring up the inventory. Here's the inventory homework, and as we come down here, I start with the time conversions, and this is a video number 2 in my website. And time conversions are going to be very important in this homework assignment and in actually this whole material, as I've mentioned in the lectures and the video, and you'll see it in the homework. So let's go through. Let's start with the questions. Okay, first of all, in part 1 here, question 1, 2, and 3, I say use videos 1, video 2, video 3 under the inventory heading. That's in the website. Okay, where are the resources for this? So this is one resource. Let's bring up Canvas. Here's Canvas. If you come down through here, one resource, a good resource right here in weeks 8 and 9, which is topic number 4, that's where we are. This video, lecture video right here, that lecture video is what I did last week, and that is what is covering the material. That's one video. This one I'm doing right now will be right here on the homework video and showing it where to find things and how to work the homework. But another resource which I'm talking about, if you go back to home and come down to the website, here's the website, mdharper.com, and then you come to Operations Management tab, come down to the heading, Introduction, there's the time conversion video, here's the forecasting, linear programming, aggregate planning. Here's the inventory, constant demand, videos 1, video 2, video 3. These 3 videos is what I'm talking about. So these videos are not necessarily lectures. They're more like presentations. I call them presentations. The lecture is what I just showed you in Canvas. And then this is also going to be just a lecture. Okay, so let's go back to the homework. That's what I'm referring to when I talk about the videos. Okay, so now this first question just comes right out of the fundamental questions, inventory theory, periodic and continuous review system, and the relationship between inventory period and lot size is just some basic fundamental relationships of the inventory fundamentals. The Q equals DT. Okay, video 2 is EOQ. And EOQ is the economic order quantity. There's the equation and there's the definitions. Now in EOQ, I'm coming down here through different definitions. This is relationships, zero safety stock, the ratio here, zero safety stock, the relationship between ordering and carrying cost. Now the answer to question 2 here, these answers a statement, not only in the video 2, but also in the lecture. Let's bring up the lecture notes. See if I can bring them up here. So bring them over. Let's bring them up. And so when you come down here, here's the introduction that I had in the lecture, and here's the overview, and there's the 2 fundamental equations of inventory theory. Coming down here, there's the fundamental equation in the sawtooth curve. Further down is ROP, and then here's EOQ. And now page 5, what is this? 5-6, here we go. This is the graph I'm talking about. So I'm really referring to this graph. Not only will this graph, the concepts within this graph will be important for the homework, I'll also ask this in the exam at the end of this course. It'll also be in the exam. So the idea here at EOQ, which is that point right there on this Q axis, there's different values of Q. Well, Q can equal EOQ, and if that's true, then the total inventory cost here is minimized, but the ordering and carrying cost are equal. So if you take the carrying cost, which is equal to this, the ordering cost, which is equal to this, set those equal together, set those equal to one another, and then do some algebra and move things around and collect terms and have C sub O divided by C sub C. And that'll be the Q over 2 divided by this. Well, Q over 2 is average inventory for zero safety stock. D over Q from the fundamental equation is order frequency. So let's come back here. That's exactly what this is talking about. This ratio represents represents the average inventory multiplied by the order frequency. Is that true or not? Okay, and then this also, statements 3 and 4 also refer to the same curve, to where if Q is more than EOQ, if Q is out here, then notice at that point the relationship between the carrying cost here and the ordering cost, or if Q is less than EOQ down here, the relationship between the ordering and carrying cost is one larger or smaller than the other. So those questions refer to this graph right here. Okay. Let me bring back all my stuff here. Okay, whoop, it went away. Let me bring it back. There's my homework. Okay, question 3 is going into the video 3 and ROP. So here I go into ROP, the ROP video. I say video 3, is that true? Let's bring this back. Boom, boom, boom. Yeah, video 3 is ROP. Is that what I said? Yeah, video 3 is ROP. There's the equation. And so here I'm talking about the safety stock, stock out level, safety stock, safety stock. Notice I have safety stock, wrote a point. I have the service level, stock out level. Again, bringing back the lecture. Bringing back the lecture here and bringing this over. Let's come back to ROP, which is up here, page 5-4. Here's where I talk about the stock out level and the service level, and I do it in the video. I do it in the lecture video, in the presentation video on the website, and here's where we talk about the relationship of ROP, safety stock, and here's safety stock over here, the relationships in the graph. Okay, so I explain that in those videos. So there's where those answers come from in the explanation. So bring this back over, and so all those should come right out of the videos, just word for word kind of thing. Should be okay. Okay. Oh, part 2. Now part 2 is questions 4, 5, and 6. Now 4, 5, and 6 again go back to the videos 1, 2, and 3 under the inventory heading. But now I move into mechanics. Well, the videos not only talk about definitions and relationships, they also talk about the mechanics on how to work the problems. Okay, so let's go through some of these and show how to work some of these problems. Okay, first of all, question 4. For an inventory item, the constant demand is 1664 items a year. The lead time is 1.5 weeks. The item cost is $9 per item. The ordering cost and the carrying cost per unit, the unit ordering cost, unit carrying cost are given. And notice that there's 1, 2, 3, 4, 5. These 5 rows here is given the same 5 rows for question 5, the same 5 rows for question 6. So I give you the same header information. I just give you this information here, and I change the information a little bit as I go down. Okay, so for this one, if the order frequency is 2.6 orders per quarter, that's my order frequency, then find the approximate inventory plus for a periodic review system. Okay, so let's bring this down like this and say periodic review system. Let's bold that just to highlight that. And remember, that policy then will be T and Q. That's the policy for a periodic review system. Let me bold that again. Boom. There we go. Okay, so therefore, I have to find T, but notice the T down here, they're in weeks, 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 weeks. Everything is in weeks. So I want T in weeks, okay? And then I need to have Q. So I need to find Q and T in weeks, okay? So I'm giving you the order frequency here. So then what's going to be T in weeks? Well, remember, here's the equation. Let me put it in brackets here. T equals 1 over F. So I'm giving you F, and 1 over the order frequency will be the inventory period, T. But the order frequency is in quarters. We need T in weeks, so you have to transform it. So how do you transform quarters to weeks? Well, let's take this down here. Let's go down again like this. The order frequency, let me bold that. So what is that going to equal? What does that equal? Well, notice that time is in the denominator. So if the order frequency, well, if you order 2.6 orders per quarter, then how do we transform quarters to weeks? I highly recommend transform it from quarters to years, years back to weeks. Okay, parenthesis. So we have 2.6, but that's orders per quarter. Well, if you're ordering 2.6 per quarter, how many orders will you be ordering for a year? You'll multiply it by 4. If you have 1 per quarter, it's 4 per year because there's 4 quarters in a year. Okay, but that's my orders per year. What is it per weeks? I divide by 52 weeks in a year. And that's going to be my orders per week. Okay, and that's what you use in this equation to get my order inventory period. Okay, and then once I have that, Q equals DT. So notice, in order to do this, you have to get this number right here. Take 1 over that to get the inventory period, and then that times my demand. Oh, my demand is in years. Aha. Okay, if this is in weeks, this has to be in weeks. Okay, so that's going to be 1664. If that's how many per year, then what's my demand per week? You divide by 52 again. And this would be items, items per week. Let me bold that. Okay, so notice you don't use all this information on the first one. You'll use the information later. But you have to start with this. And there you have it. So now for that order frequency, you know what your... so you have to do the arithmetic and see if one of these is true or none of the above. So that's how you work it. So question 5. If the safety stock is 10, find the approximate optimal inventory policy that minimizes the total cost for a contingency system. Okay. Now notice what we have. We have a continuous. Let me bold this again. I want to bold it to highlight it. Continuous but it's an optimal inventory policy. Continuous optimal review policy. And that's going to be ROP, and optimal would be EOQ. So I'm optimizing, I'm minimizing costs. An optimal inventory policy would be EOQ. So now I have to do ROP and I have to do EOQ. Well, ROP equals demand times lead time plus safety stock. And that's why I gave you the safety stock. There's a safety stock. Well, we have the lead time up here. Sure enough, there it is. Demand times lead time split. Okay, my demand again is in years. Fine, I come back up here. I know I have to do this. So let me highlight control and put it down here. Let's bring it down here. I know I'm going to need that in weeks. Because if my demand is, if my lead time is in weeks, I keep using this, so let's just open it up. If my lead time is in weeks, my demand has to be in weeks. I add that times safety stock, and that's my ROP. Now, ROP is over here. It's either 48, 58, 42. It's one of those. or it's none of the above. But then I need my lot size Q. So again, Q equals dt, okay? Well, I want EO. I don't need E. I don't think I need EOQ. EOQ equals square root 2 times C sub O divided by C sub C. C sub O divided by C sub C. Oh wow, I'm having so much trouble with this. There it is. Now I got it. Okay. So again, optimal review policy would be EOQ. I said it there, so we need the EOQ. Okay, so 2 times demand times, there we go. Square root of 2 times demand times C sub C. Oh, well, if my demand, well, this is in years, this is in weeks. I have my carrying cost down here. It's in quarters, okay? So whatever my demand years are, whatever time units I have in my demand in the numerator up here, I need the same time units in the denominator. Well, I think the easiest thing to do, what I would suggest, if my cost is $23.40 per quarter, I'll just say 23.4 times 4 quarters. That'll be my dollars per item per year. Okay, I'll just transform it that way. Okay, so now I can calculate my ROP in weeks. I have that up here, and my safety stock is 10, right? Because I need that for sure. So that, and then my D is in years. Then my ordering cost is just that. I need that. And then finally, my carrying cost is in years. And again, transformations are important. So when you get ROP and EOQ, and see which one of these it is. Okay. Now question 6, and that's how you solve question 5. Question 6, for an inventory, okay, I give the same header information. For an inventory policy, I give the inventory policy, find the approximate total annual inventory cost. Okay, in that case, here we go. And so now the total annual inventory cost equals the sum of the total annual carrying and ordering cost. Okay, in other words, let me bring this down also and say TIC equals TOC plus TCC. Okay, that's what that means. And so I want the total annual inventory cost. That's what I'm asking for. But I give you the inventory policy, and there it is. Aha. Okay. Well, first of all, the total ordering cost will equal my D over Q, and that's going to be my order frequency, times C sub O. TCC equals Q over 2 plus safety stock times C sub C. So I have to get all those values. Okay. Well, we have our demand up here in years, and we have our Q. Here's our demand in years. Okay. Q is given 180. Okay, let me do it this way. This equals ROP Q. Okay, so ROP is 60 and Q is 180. So we have those two numbers. Here's demand. And so D over Q times C sub O, well, we need these carrying costs. We're going to need pretty much all these things. Okay. So D over Q times C sub O, here's D in years, over Q, which is 180, times C sub O, which is 145. So that'll be my ordering cost in years. Okay. Now my carrying cost. I have my Q 180. There's Q here, but I don't know what my safety stock is. Okay. My carrying cost is given here. Per quarter, okay, I want it per year equals 23.4 times, if that's per quarter times 4, that's going to be my cost per item per year. So I'll need the annual cost for my carrying cost here, and I got that. That's that number. My Q is the 180, and there it is. Safety stock. I don't have safety stock. So I have to calculate safety stock from my ROP. Well, let's do that down here. ROP equals demand times lead time plus safety stock. So my safety stock is going to equal my ROP minus demand times lead time. Okay. My ROP is 60 minus my demand. Okay, got to be careful here. My demand times lead time. Well, my lead time is in weeks. So demand times lead time, if that's in weeks, then my demand must be in weeks. So that'll be 1664. If that's per year divided by 52, that'll be my items per week. Okay, so this would be minus my demand, which is this, 1664 slash 52 times my lead time, which is 1.5. Okay, and so that's going to be my safety stock. So notice I have my Q, that's given 180 over 2. My C sub C is given. My safety stock has to be calculated. It's that number right there. Get the safety stock, put that in there. Then you add those two numbers together and see if the answer is here or if it's none of the above. Okay, so that's how you do question number 6. Okay, part 3, 7, 8, 9. Okay, again, what I do here is similar to the previous 3, but what I do, I take the fundamental relationship, Q equals dt, ROP, EOQ, and essentially I ask different parts of the same equation. Okay, so for Q equals dt here, I have the demand. Again, it's the same demand. Inventory period is 3 months. Okay, let me just say T equals 3 months. And that's all I have. So I have Q equals dt. But down here I say, what's my lot size? What's my annual order frequency, annual turnover rate, annual inventory period? Okay. So on all of these, let me come out here. I want Q. On this one, I want order frequency, but it's my annual order frequency. This one, whoops. This one, I want my turnover rate, but it's my annual turnover rate. And this one, I want my inventory period, T, but my annual inventory period in years, inventory period in years. Okay, so that's what I'm asking. And notice all of this comes from the Q equals dt or Q equals d over F. Okay, so here, I'm just going to put these equations in here a little bit. F equals, let me do it this way. Bold these, bold this, and bold this. We want to be bold, don't we? Because we want to because we're bold with the right answer here. So if Q equals D over T, Q equals dt, let's say dt, equals my demand times, but if this demand is in years, my inventory period also must be in years. Okay, so that's going to equal 3 divided by 12 years. Because 3 months is 3/12 of a year. So you divide by 12 to have 3/12 of a year. Okay, and so again, I'll say it this way. The D is in years and the T is in years. Okay, so there that is. What's the frequency? The frequency equals 1 over T. Okay, but you have to use the T in years because we want the annual frequency in years. Okay, the annual turnover rate. Well, the turnover rate for this problem equals 2, for everything we do in this course, is 2 times the frequency. Turnover rate is 2F. So whatever that is. Okay, now I'm just giving you the equations here. Get everything organized over here on the right. So you're just plugging and cranking, okay? And T, the annual inventory, okay? The monthly inventory period is 3 months. The annual inventory period is 3 over 12 is that, okay? And so that's just going to be T in years. So that's what you just said. And all these others are going to be the same way. Very, very similar. Okay. Like ROP. On this one, I give constant demand rate. On each one of these, notice I have, let's bring this down here. The lead time is 1 week. Safety stock is 12. Reorder point is 50. Reorder point. So I have the reorder, I have the ROP, I have the lead time and safety stock. So I give all 3 of them, and basically you say, do they all fit? Are all the numbers correct? In other words, notice my lead time is 1 week, my lead time is 1 week, lead time is 1 week, and so every time it's 1 week. So I'm going to be transforming this to a weekly. 1664 divided by 52, and that's going to be items per week. So I'll be using this demand right there. Okay, and using that demand down here, I have ROP equals demand times lead time plus safety stock. And so my point here, what this question is really asking is that for each one of these, I give you the 3 numbers, but I give you 3 different numbers. So here I have 1 week, 12, and 50. Here I have 1 week, 40, and 20. Here I have 1 week, 10, and 60. Here I have 1 week, 40, and 10. Okay, well, you got to put them into this equation, see if they work. See if it's that way. Well, you have one. Well, notice each time it's 1 week. So 1 times this will be the same for each one of these statements, statements 1, 2, and 3, and 4. So it's going to be the same for each one of those statements. 1 times that number there, whatever it is. Then the question is, so this has a safety stock of 12, this is a safety stock of 20, this has a safety stock of 10, this has a safety stock of 10. So the question is, if you add that to this number, does that equal the ROP they give you? And so it's just going down and seeing which one of those are true. Now, statement 4 is a little bit different. If the safety stock is 10, the lead time is 1, the reorder point is 4, then the average inventory during the lead time immediately after the order is placed is 30. Okay, interesting. Interesting because it's a very good problem. It's something that's important. something valuable that can be used in industry. So let's bring back the lecture. And notice during the lead time, right here, during this lead time, where the order is placed right here, or during this lead time, I'm going to have, I'm going to make sure you can see it. Yeah, I have this from here's my safety stock. And I carry the safety stock that whole lead time. But right here from this point to this point, here's my Q. Here's my ROP right here, my demand times lead time. And it goes from my demand times lead right from that point up to there. That's that value there. And it goes down to here. So over here, here's my demand times lead time, and it goes to 0. So my Q over my demand times lead time, there's our ROP, over that, it's going to be that ROP divided by plus 0 over 2. It's going to be half of that as my average. So it's going to be average of this plus this inventory. Okay, so let's come back here. Let's see here. So the average inventory is going to be my demand times lead time. So that's how much that is, right? Divided by 2, okay, but then it's going to be plus my safety stock. Whoops, parentheses. So I'm carrying my safety stock the whole time, but my demand times lead time, that's going to go away. So only half of that will be my average inventory for that part. But then the average inventory, I'm carrying safety stock the whole time. So that's going to be the equation. That's the equation for this one here. Okay. Let's see here. Aha. But I have, is the reorder point, is this true? Okay, let's come back down here. We also have two things going on. ROP equals demand times lead time plus safety stock. So the question is this, if this is true, is it true? If that is the three values for this, do they fit? If it is true, then is this the correct average inventory during lead time? Okay, so I have demand times lead time here plus safety stock. If this is the reorder point, if this is my reorder point, then is that my safety stock and lead time? Is that going to be true? And if that is true, then is this going to represent my average inventory? So first of all, is the first part true? If that is true, is the second part true? Okay, so there's a couple things going on there. Okay. So that one, that last statement number there is a little bit trickier, okay? And so you got to be careful. Got to be careful. Okay, question number 9. Then I go into EOQ. Same with EOQ. Okay, now the EOQ you can see here. For EOQ here, again, I'm giving the demand rate, the ordering cost, and carrying cost. So I'm giving you everything you need for EOQ. But then what's the EOQ? At EOQ, the total weekly ordering cost, the total quarterly carrying cost, the annual inventory cost. Aha. Okay, well that's going to be a little bit tricky here. The question is, first you got to find EOQ. And EOQ is given to be this right here. Let me just go ahead and just copy that down. Okay, and that's pretty much going to be that answer there. Okay, right. And that's pretty much what that is. Now, again, the units you got to be careful with the units. This is in years. My carrying cost is in weeks. Okay. And I guess what I would recommend is just this right here. I would keep this in years. And this right here, my carrying cost, unit carrying cost in weeks, I would 2.5 times 52 weeks in a year. And that's going to be dollars per item per week. Okay, I would transform the carrying cost to weeks. Per year. I multiply by 52. So if that's the cost per week times that is going to be per year. So I would transform this to years. Okay. And then use that for my demand, this for my ordering cost, and that number right there for my carrying cost. And whatever that EOQ, and see if that's true. But whatever that is, that's going to be my EOQ for these others down here. Okay. Now remember, the total ordering cost equals D over Q, D over EOQ, in this case, times C sub O. So we're going to have EOQ up here. So demand over EOQ times C sub O. If I use this demand up here, right here, that's my total ordering cost per year. Okay. And if I want to know what my total ordering cost per week is, then I would just divide by 52. That's all you do. Now this one is my carrying cost. Total carrying cost equals EOQ over 2, or Q over 2, EOQ over 2. And we have 0 safety stock. Okay, so there's no safety stock. I'll go ahead and say plus 0 because there's 0 safety stock times C sub O, or C sub C. Okay, and the C sub C I would use is the carrying cost per year. And so this right here then would be my total carrying cost per year. If I want to know my total carrying cost per quarter, then I divide that by 4. And that's all you do. Okay. And then that my total inventory cost equals my total ordering cost plus my total carrying cost. And this is annual. Annual. This is weekly. And that's why that's 52. This is quarterly. And that's why I'm dividing that by 4. And this is annual, and that's why I'm just taking these the first part here, the first part here, and just adding it together. Okay. I guess what I could have done here, I could have done this. DOC over 52. Could have done that, but I didn't. Okay, I've explained it. Okay, and that's how you work number 9. Now, number 10, 10 here is quantity discounts. Okay, the inventory manager. So now the last one is I broaden it up, and it's like a real problem. This is a really popular problem in industry today. the inventory manager has typically ordered a quantity of 500 each time an order is needed for one of their popular tires to take advantage of the discount provided by the supplier and save the company money. Well, that's a good thing. That's a very good thing, right? And so what is he doing? He's saying, okay, let me pull things up here. He's saying, okay, well, I see here the tire cost the tire from the supplier is $80 per tire. Okay, and so, but if I buy 200 or more, if I buy between 200 and 499 number of tires, they'll give me a 5% discount and only charge me $76 per tire. I'll save $4 per tire. That's a lot of savings. And if I buy 500 or more tires, I can get a 10% discount and save $8 per tire. That's even better. Well, the manager says, I want to save this company money, so I'm going to order 500 tires every time I need to order something. I'm going to order 500 tires, and I have all the 500 tires in there that every time I order, because I get the maximum discount. Well, that's a good idea, and it will save $8 per tire, okay? But the following discount schedule has just been received, reflecting recent changes in some of the discount percentages. The manager still maintains that an order quantity of 500 will save the company the most money because of the quantity discount. He says, fine, I don't care, these numbers have changed, but still, from these numbers, I can still save 10% and save $8 per tire. Okay, well, last year, for an annual demand of 1,000 tires and a lot size of 500, which resulted in acquisition cost of $72, they had a total ordering cost of $380, total carrying cost of $342. What this is saying is, well, last year, he did it last year. And last year, the annual demand is 1,000. He ordered 500 each time, okay? So the acquisition cost was $72. We can see that right here. The acquisition cost was $72. But they had a total carrying cost of $380, ordering cost of $380, a total carrying cost of $34,200. That's how much it cost to order, and that's how much it cost to carry. Okay, they forecast an annual demand of 1,000 tires again for this year, and their unit carrying cost per dollar of inventory and the unit ordering cost per dollar per order for this year is assumed to be the same as last year. Now notice the unit carrying cost per dollar. Let me highlight that. And remember, let's bring back our lecture. Remember when I in the lecture, when I came down to quantity discount, remember it was the carrying cost was cost per dollar per year. So we're going to be using, and this is on page 5-9 in the lecture notes, this is what we'll be using. Okay? And so the carrying cost per dollar is the same last year for this year. Since the demand last year was 1,000, lot size of 500 was placed, they had an annual frequency of 2. Does that make sense? The demand is 1,000. You place 500 each time you place an order, so you're going to order 500 2 times over the year because the annual demand is 1,000. So the annual frequency is 2. Since last year the lot size is 500, no safety stock, they had an average annual inventory of 250 items. Okay, well, the average inventory, if the lot size was 500 to 0 safety stock, it goes from 500 to 0, 500 to 0. Well, the average inventory is 250. Okay, but we do not have the unit carrying cost and unit ordering cost. So this problem, the first thing you do is you say, what is my unit carrying cost per dollar? What is that? Okay. question mark? Well, we can see here that the total carrying cost equals 34200. I brought that up down here. The total carrying cost is 34200. And that's going to equal my Q over 2, 0 safety stock, oops, plus 0, times my I times C. Remember, again, let's bring back the my lecture, and remember that IC is the same as carrying cost. The carrying cost per dollar times C, the acquisition cost or the item cost. Okay, so let's come back here, and that's what I'm doing here, I times C. Well, I know what Q is. My lot size is 500 divided by 2 plus 0 times I, that's what I want, times C. I have C up here, which is 72. Okay, so right there, I equals what? Well, right there is how you calculate the item cost from the numbers given. So the total carrying cost is that, which is equal to this. But then Q is 500, I is what we're trying to find, C equals 72. So you solve that equation there for I. You solve the equation for I. Okay, and so some of you are probably, are probably good at that. The 500 over 2 is 250 times 72. Well, I is going to be the 334200 divided by the 250 times 72. Okay, and I'll let you do the arithmetic. You got Excel to do that for you. Divide by 250 times 72. Okay, but then what's the unit ordering cost? Per order equals what? Total ordering cost equals the order frequency times C sub O. Right? Well, the order frequency is given to be 2. The total ordering cost is given up here. The total ordering cost is 380. And so you put 2 in there, you put 380 over here, and then C sub O equals the total ordering cost divided by F. And so you can do the arithmetic. So now that we have I, we have C sub O, we have our demand, okay, now what we're going to be doing is going through these calculations step by step by step, okay. We have our demand, we have our ordering cost, we have our carrying cost per dollar per year, and over here we have our item costs. Okay, there's our item costs. This right here is the carrying cost. The carrying cost per dollar per year, and this is the ordering cost per order. So then we go through those steps. Now, at this point, I've shown how to get all these numbers. And so essentially, you go through step by step by step, just like I did in the video, just like I did in the lecture. And I won't do it again. I'll let you do it. Okay? And I would suggest using Excel. And so I'll leave this for you to do. I don't want to steal your thunder. I want you to put all those numbers in there and then just have everything, have it all come out. And it's one of these. And notice the answer here, inventory period in weeks, months, quarters, or years, with none of the above. And so which one of these is correct? Okay. So it's a review. It's a periodic review system. its inventory period, comma, lot size. Okay, well, that's how you set this up. And then the lecture here and also the video is how you add, actually, not the basic EOQ. It's going to be the quantity discounts down here. And this right here on page 5-9, it's exactly how you work it out. And I'll leave that for you to work out. So that's all I have for the homework. I hope this helps. If you have any questions, use any questions on this. Again, I want to start highly recommending that and encouraging people in the week 4 here. Use the Q&A right here. Go to Q&A. Nobody has used it. If you have any questions, go to the Q&A. I'm going to start going here to see if anyone has questions. I'm not going to go to my email again because that hasn't been working out very well. My email doesn't always get to me. So I'm going to go to the Q&A. And if I see a question, then I'll say, post it in Q&A and I'll answer it. Because then everyone can see the answer. Much more efficient. Okay, so that's all I have for today. I encourage you to use all the resources, use each other, collaborate. And if you have any questions, post it on Q&A and I will answer it so everyone can see the answer. If you want to talk to me with a conversation, I have office hours Monday, Wednesday, Friday at 7. I didn't last night because it was closed. We were told that everything was closed. But I'll be there on Wednesday night and Friday night at 7. That's all I have. Between now and the next time I see you, I want to encourage everyone to be safe. And between now and the next time I see you,